So let's talk about some Java EE authentication mechanisms and some basic security features that you can implement in your application within the Java EE specification. The JEE specification covers the following mechanisms for authentication of a web application. It handles HTTP basic authentication, and when you use this mechanism, you're using the web browser to display its own built-in pop-up challenge, if you will, generally user ID and password for the user to type in for your application. There's also support for form-based authentication. When you use this mechanism, it allows the developer, the application developer, to provide a custom login page just for this application. There's also support for client certificate authentication. This mechanism uses traditional SSL certificates to authenticate both the server to the user and the user to the server. The communication is encrypted over standard SSL encryption, and no user passwords are sent. There's also support for HTTP digest authentication. This mechanism is similar to HTTP basic authentication, but it sends passwords in encrypted form. The implementation of this, however, is optional in the JEE specification or the Java EE specification. You may have to double check for server vendors because some server vendors may not support it as they are not required to. So what does basic authentication look like in our application? It is the default authentication mechanism. A pop-up challenge window comes up from the browser, within the browser, and accepts user ID and password. So the actual screen that the user would see would depend on the actual browser that they're using. The passwords are sent in simple base4 encoding back to the server. In Java EE, this gets activated as soon as you define at least one what is called security constraint. In other words, the user accesses one resource that has security applied to it. You have to enable application security on the application server, so this involves some security configuration on a respective application server. For form-based authentication, the user ID and password fields are submitted in a custom login page within HTML or within JSP. The username and password combination is generally sent in plain text. Form-based authentication tends to be a more preferred version to HTTP Basic because HTTP Basic tends to cache credentials in the browser, and the user cannot be logged out unless the browser is actually closed, whereas with form-based authentication, you can provide a log out routine. To configure form-based authentication, you add a login config element to the web deployment descriptor in order to configure this. For example, here's a very simple example of the login config element, what it might look like to configure form-based authentication within my application. Notice that the auth method is set to form. The form login config element has two child elements, one for the login page and one for the error page. And notice we're pointing to JSPs in this area. It doesn't have to be JSPs, but we're pointing to JSPs because we're looking at this from a servlet and JSP developer perspective. If you're looking at using form-based authentication, there's a sequence of operations that gets followed when the login.jsp is submitted. The server performs any authentication that is necessary. The server then redirects to the login page if the user is unauthorized. If authorized after the form is submitted, the resource is shown, otherwise an error page is displayed as defined in the login config element. The JEE specification does specify how the login form needs to be built to work with this out of the box. The form must be authenticated through a post action method, standard HTML post action method. The post action must be actually named J_security_check. The username and password fields, without additional configuration, if you're using the straight out of the box stuff, the username and password field must be J_username for the username and the J_password for the password field. So here we see a sample form of what this might look like put together. Notice this is straight HTML, which we can, of course, use in our JSPs. The name of the action is specific. The method is post. And then we have at least two fields for username and password, and the names of those fields actually correspond to the Java EE specification, the JSP specification for form-based authentication. The Java EE specification, however, does not specify any logout methods, so you would have to handle that in the logic of your application. If you're considering client certificate authentication, the web server needs to be configured to perform normal SSL functions, in other words, mutual trust between the user and the server. This generally happens as what they call a handshake, where the client and the web server exchange certificate information during what's called an SSL handshake. To specify that your application uses this type of certificate or this type of authentication, client certificate, then you use client-cert as the authentication method in the web deployment descriptor. So again, we see our login config element. In the auth method element, we specify in caps client-cert. The credentials from an X509 certificate generally is presented to whatever user registry is configured on the application server or the web server. The application server searches the registry, so there must be some security service mechanism in the application server to be able to validate the credentials that are passed in with the certificate against whatever user registry is configured in your environment. The matching logic could be customizable based on the application server. That's kind of outside the scope of this class, but there are certainly application developers who write the whole security logic within an application architecture. In other words, you should be able to map attributes from the certificate to the user's attributes in LDAP. That's not really JSP specific. That's kind of an SSL thing and an overall security architecture thing being the technical term. It's an overall security architecture topic. Once you define how credentials are captured and the system administrators have configured security in their environment, the next step that happens in this chain is that an application discovers, or the security service, once a user is authenticated, the security service needs to be able to also possibly determine, once you're authenticated, what is it that you're allowed to do. And this is referred to as authorization. Authorization is the next step that can be implemented to determine, once you're into the system, what is it you're allowed to do with the resources we provide. The Java EE specification does in fact cover authorization for Java EE applications. After a user is authenticated, then that user can be authorized or not authorized to access any resources within a Java EE application, access any resources that are protected using the Java EE specification. JEE offers role-based authorizations that grant access to the resources which are based on the user's security role and security role membership. The authorization can be implemented either declaratively and or programmatically, and a mixture of both. Declarative security allows you to define constraints, in other words, security constraints, through the application deployment descriptor or by providing annotation in the code to define these security constraints. Programmatic security is used to implement fine-grained access decision logic from inside of the application component, giving the programmer a little more control. The authorization protection model is applied in a Java EE application to both web applications and EJB applications. Declarative security, using declarative security on web resources. The main benefit of the declarative approach to configuring role-based security settings is having the ability to change security settings according to the client needs without changing the application code. This is one of the benefits of any declarative approach, not just declarative security within web application. To accomplish this, it's done by defining a security role inside the web deployment descriptor. The security role is then used to access certain web resources, artifacts within my web application. A security role is actually just a logical group of principles that can be authenticated, usually a group of users. A security constraint is a declaration of how to protect a resource or a group of resources. Configuring declarative security involves at least 3 steps. We need to be able to define security roles for the application. We need to define security constraints for the application, and this involves 3 elements, essentially. Web resource collection, which is the list of URL patterns and URL addressable objects that will be protected. The authorization constraints, in other words, which roles are authorized to access this web resource collection. And then we have an element for user data constraints, which define the transport layer security. Your options here are confidential, integral, or non. An example would be, again, looking at the deployment descriptor, the web deployment descriptor, we would see a security role element at the top. Actually, we've got 2 security role elements at the top. One role for customer, one role for admin. This is the actual name of the role. Now, keep in mind when this application is deployed, these application-specific role names would have to be mapped to actual principals in the server user registry, usually an LDAP registry. So these roles are used locally, but as part of deploying a JEE application, the server has to be able to handle mapping these roles to actual principals in a real user registry when the application is deployed. After 2 security roles within my WebXML, I've got 1 security constraint. And within the security constraint, I've got a web resource collection element, giving it a name, and defining a URL pattern applying to all URLs. Additionally, this web resource collection is being applied using the HTTP method element, applying to all HTTP GET methods, all HTTP POST methods. So this is an interesting piece of Java EE security, that these web resource collections, it's not just the artifacts in our application, but we can actually apply these constraints, these security constraints, to HTTP methods. And I'm saying in this security constraint with an auth constraint and a user data constraint, with the auth constraint specifically, I'm saying that I'm going to use the role customer and the role admin for this security constraint. In other words, the resources in this security constraint are constrained to only be allowed to be accessed by members of these roles. I don't have to know what the actual members of these roles are. As a matter of fact, I shouldn't. That's determined by the role mapping that's handled at runtime when the application is actually deployed. For my transport guarantee, I'm using the user data constraint element. to define confidential as my transport layer. For application programmers to provide programmatic security on web resources, the application developers actually write security code using the JEE security APIs that are relevant for the particular piece of code that they're writing. This is used to make additional security logic decisions, for example, hide parts of a GUI control or provide additional security and additional security logic within method calls, if this user is in this role, that kind of thing. The JEE Security API gives us a number of methods, but three particularly interesting security methods to get information about a user. There's getRemoteUser, which returns the username, whatever the client used, in order to log in. This returns a string. There's getUserPrincipal, which returns a principal object, which we can interrogate with methods using the principal API or the principal object. There is a method called isUserInRole, and this is actually commonly used to double check in your logic because you don't really know what the role membership actually is when the application is deployed, nor should you know. You're applying role security to your application artifacts. isUserInRole returns a Boolean and allows us to check to see if the calling user is in a specific role. So, for example, in JSP code, we might see just this. Notice that getRemoteUser, getUserPrincipal, etc. This is Java code. So we're writing Java expressions and Java scriptlets in our JSP code, but it gives us an idea of how we can determine role membership and write some additional application logic in our application artifacts. A security role reference. Security role references provide us a level of indirection in order to isolate the role names that are used by the developers in the code, and we're isolating those names from the actual runtime role names. Security role references are defined and linked to security roles by using the web deployment descriptor. A reference provides a way to bind a role name that is used in the code to a security role that is announced in the deployment descriptor. We see an example here where in our web deployment descriptor, within our servlet mapping, which is generally what we're looking at in deployment descriptor, we're looking at various mapping elements, but we've looked at simple servlets all along. In addition to defining the display name, the servlet class, which we've already seen, we're adding an element here, security role ref, and we're using the role name and the role link elements. In our code, we would use admin ref. The role link to the application-wide role is what's defined under role link. And so what we're doing with security role ref is we're saying, I have some resources in this servlet. I need to be able to interrogate the membership of these roles. Now, alternatively, in Java EE, we can use annotations. Annotations are a new ability in Java EE5 that allow us to annotate inside of our Java code what is normally necessary to do, as we saw in the previous example. It has previously and historically been necessary to configure everything in WebXML. The use of annotations in our Java code allows us to decorate, if you will, or annotate our code right in the Java code, what would normally be created in XML. So we can stay in one editor, one familiar IDE, and use a couple of very specific tags to annotate our code. The use of annotations in a web module is very limited right now. There are only 2 annotations that are available currently to web artifacts. One is @declare roles, or the declare roles annotation, and the run as annotation. You can also define application-wide security roles by using an annotation called @declare roles. The @declare roles annotation is specified only at the class level, and it's used to define roles that can be tested when you're doing an is-user in-role evaluation. Here we see an example of how to define a role reference using @declare roles. Notice that I've annotated the declaration of my class, public class secured servlet extends HTTP servlet, and right above that, this is where annotations go to signal to the system that this is in fact an annotation and it's applied to this next element. So generally you see annotations right before what they're annotating in the code. Annotations have to be interpreted before the code can be compiled, so placement becomes a little tricky, a little picky here when we're looking at it. But here we're using @declare roles and annotating our class secured servlet, and saying when we use the @declare roles annotation, parentheses, curly brackets, quotes, this is the role I'm declaring. I might be looking for the membership of this role. And sure enough, inside the rest of my code, which is off the slide, I see a logical test for if, and my logical if conditional test using the request object .isUserEnroll public, and only execute that code if the user is in fact enroll. Notice I don't have to know what the role membership is. I've declared that I'm using this role. The role reference is created for me, and when the application is deployed, I've got to have some way of understanding how this role public would be used in the real production server runtime environment. So the administrator is going to have to resolve that to actual principles from their actual user registry. But it allows me as a developer to write off-the-shelf applications that could be bought and purchased and configured by any number of customers that are running Java EE servers. Now, delegation is an important concept for servlet and JSP developers to understand. When a servlet calls on an EJB, an enterprise Java bean is what EJB stands for, the security is actually handled a little differently. The servlet does not actually make the method call. The application server is handling the containment of web application resources compared to EJB resources, and a call is made within the application server itself, or possibly to an EJB in another application server, in other words, outside of the JVM. So when a servlet calls a method on an EJB, by default, the principal is propagated to the EJB. In other words, the user information is propagated to the EJB. However, the Java EE specification allows for, and it sometimes makes sense that when we call a method on an EJB, the EJB expects, for its security needs, expects a specific identity. It may be desirable at that time to change the caller identity in this particular instance. In order to do this, in order to accomplish this within a servlet, then you're looking at configuring what are called the delegation settings or the run as settings. The run as settings can be set through web deployment, and there's also an annotation if you don't want to work with the XML. So you can annotate your code to also specify run as roles or run as identities if your servlet is expected to change the caller identity before calling a method on an EJB. Delegation settings affect all calls from the servlet to the enterprise bean, as we'll see in just a second. So an example for using both annotation and descriptor, or using one or the other. But just to show you what this might look like, if I'm using the web deployment descriptor to define a run as role, again, I'm adding another element in the deployment descriptor to my servlet element, and the element is called run as. If I'm annotating my code, I can annotate it at the class level. Yes, these annotations can be stacked. So if I'm using annotations instead of the actual deployment descriptor, at run as system, at run as admin, and you declare what the actual identity is, at declare roles system. So the role names don't necessarily match between these two examples, but we get snippets of code that show us exactly where we would declare run as elements. When an EJB calls a method on another EJB, the identity of the first caller is, by default, propagated to the next EJB, whether they're in the same application server or another. In this way, all EJB methods in the calling chain would see the same principle as if they were to call the getCaller principal method, if they were to call that. Occasionally, however, it's desirable for one EJB call or for one EJB to call another EJB and intercept the previously identified identity and change it. For instance, one that is member of a specific role. The EJB specification allows delegation only at the bean level, not at, as we saw with the application server or with the servlet, at the class level. However, the EJB specification also uses the annotation at run as. It uses this security annotation to define the role that will be used for delegation. When we use this, all methods of a particular bean will call the other beans under a specific role as defined with the at run as annotation. This role, just like in our web deployment descriptor, if you're using at role or at run as, this role can be defined either by using security annotation or using the respective deployment descriptor. Give you a visual of this. I know it's not really part of our, it's kind of outside the scope of our servlet and JSP education here. Just to give you an idea so that you can have an awareness of the vocabulary sometimes that EJB developers use. In the diagram, what we see here, EJB1, in other words, these are running in an application server. There's an instance of an EJB called EJB1. EJB1 is delegated to run as. In other words, we've defined a run as role on EJB1 to run as R1. We also have, at the application level, a user identity of C2 that's mapped to run as R1. This means effectively that C2 is effectively the caller for any calls that are made to EJB2. If EJB2 were to call another EJB, say EJB3, which is not in our diagram, the caller would appear to be C2, or the caller identity 2, because that's the caller identity that gets passed down from EJB1 to EJB2. The identity is now C2 because C2 was mapped to run as R1, and the EJB1 in the chain being 1, 2, 3, let's assume, has a run as role for R1. And if C2 is a member of R1 and C2 has that mapping to run as R1, even though the identity is C2, we're good to go. So a little snippet of EJB code. It's really kind of outside the scope of here, but you see that we're using the same annotations, declare roles, run as role, in EJB notation that we would in our web application code. Now let's see if we can take a look at effectively using Java EE security to apply some simple security to our application in Eclipse. So let's look at applying some application level security to our web application. The first thing that I need to do as an application developer is modify the deployment descriptor, the web XML, to create the configuration entities that are necessary for configuring the application. In other words, working with the security services provided by the application server. I'm going to open web XML. And this is our traditional deployment descriptor that we've been working with. This is actually the required deployment descriptor for Java EE. And there are a couple of entities that I need to add to my web XML for security. And through the magic of copy and paste, I've got them here. I'm going to add a security constraint, okay? Security constraint, you may remember, it will look through what we've got here. Oops. Too much copy and paste. Too much copy and paste is not a good thing. I'm creating my security constraint. It's giving me an error because I didn't put the close tag in. We'll look at it in just a second. Remember, a security constraint is applied to a collection of web resources. I give it a name so that it shows up in the tooling in the list for web resource name. And I'm constraining using URL pattern elements, using HTTP methods, HTTP method elements. I'm constraining the HTTP GET method, the HTTP POST method. So logically, this should make sense with what we have so far. But let's piece by piece put in more of what's necessary to define the configuration in our web XML. I'm going to create something called an auth constraint. An auth constraint within my security constraint. Auth constraint and the auth constraint tag allows me to say I'm using a role within my application. The role that I'm going to use is admin. Okay, so far so good. I'm creating a local name for a local role that I can use within my application, and I'm assigning that as the authorization constraint for my security constraint. More pieces are necessary. I can see that the tool is not happy with me just yet. But that's the end of my definition for security constraint. So I can go ahead and put the close tag in for security constraint. Now, what I also need to add to WebXML is the configuration for the security role itself. Sometimes this is done in application XML if we're packaging into large EAR file, what they refer to as an EAR file or an enterprise application. But because I'm not using that in my deployment, I'm just deploying the WAR file or the web application, I can go ahead and configure the security role in my web XML. Usually, like I said, this is done in application XML, and you have multiple modules within the application. In other words, multiple WAR files, multiple jar files, and this would be declared globally at the EAR file level. But we're just working with the application right now, so we'll go ahead and use the security role element and the role name element in our web XML. Now what I want to do is provide to my application, I want to be able to provide an authorization mechanism. In other words, how is it that I'm going to capture my user ID and password? So we remember from the specification for JSPs that this is done by using a login config element. And I'm going to paste this in, and we'll talk about that. The login config element, and before before my colleagues see how messed up my indentation is, I'll quickly go to the source and choose format so that we can see the hierarchy. We can also switch over to the design view and see the hierarchy of these elements. But again, I've been given the evil eye before because when I ask for help from colleagues, what am I doing wrong here? They want to see it formatted so that it makes sense to them. So the login config element is attached to the web app element, as is the security role, as is the security constraint in the XML hierarchy. You can see it in the outline view over here on the right. The login config element allows me to define my authorization method. In JSP, I'm going to use form. And then within that, I use the form config element, the form login config element, to define the login page and the login error page. In other words, when a constrained resource is requested, how is the system going to ask for credentials from the user? So in my application, because I'm constraining every URL, including HTTP methods get and post, anything in this application is going to be considered constrained. The system will then look for my login config element, look for my authorization method. It determines that I'm using form. If any URL is requested, it's going to present a login JSP. If there's an error in the login, then of course it will present the login error JSP. Now, it's a good idea here, especially since I've been copying and pasting things in, to save the XML. And we are talking about a Java EE standard XML deployment descriptor, WebXML. I want to make sure in my tool, as a sanity check, to right-click on WebXML and choose Validate. The tool will then make sure that the composition of your WebXML conforms to the schema that's defined in the outermost element of this WebXML. And I see that I have the validation is completed with no errors or warnings. Yay, so far so good. My server is saying I need to be republished, but let's look at a couple of other things before we actually republish that. Our form config, our form login config, is pointing to login JSP, login error JSP. I went ahead and added these to the web application, but let's take a look at them. Very simple. We're using the form tag. We're using the standard JSP syntax where the action is actually J_security_check, and the method is post. Two very simple fields to capture the username and capture the password. But the names of those fields, as you can see, are specific to the JSP API, J_username, J_password. This will get us to the point where we can actually do some testing. If you have customized login modules, customized login pages, of course you're going to want to do something a little more sophisticated. But this will, we'll get to see what's going on. The only thing that's going to happen in our login error page, by the way, is the same thing. So the system will present again the same page, only the JSP is called login error.jsp, but it's doing the same thing. So if there's any login error, wrong password typed in, whatever, then the user should see the same prompt for password. Okay, that's all our application needs to do. Now, one of the challenges for developers in testing this is to test it in an environment where you don't really have control over, ultimately you shouldn't have control over who is in this admin role. So all of our resources are now secured by something called the admin role. This is part of the Java EE specification that we can provide these security roles. We can use them to secure resources, as we've done in our web resource collection. But how do we test this on a test server where there's no real effective way to deploy our test server to talk to a real production user registry for the authentication mechanism, right? Our application is providing the authorization mechanism, but our server needs to be able to provide the authentication mechanism for our application. there are a couple of files in the configuration of a basic JBoss server, and I'd like us to take a look at what it is we can do to configure a basic JBoss test environment for security. So inside of Eclipse, I'm going to open a couple of standard JBoss files, particularly a file called login config. And notice login config is in the JBoss environment, the default configuration environment. It's standard in the deployed server. And I'm going to go ahead and open that up. And what this has is a number of templates for loading authentication modules in JBoss. And by default, a number of these get loaded. We have configured identity, we have users roles login module for the JMX console, for the web console. And down here I added, because I didn't want to modify web console that actually affects the domain that's used by the JBoss applications. I actually copied this template, application policy, and I gave it my own name so that it's only applied for my application. I can configure it within that scope. But I copied the same information from the above web console. I just gave it a unique mapping. The login module, notice the login module is users role login module, and it's clearly documented to be a test for working with role login for Java EE applications. It uses two files, and this is where the user registry comes into play. Instead of actually configuring JBoss at this time and getting into the nits and bits of things that are not really what I should be paying attention to other than configuring my test environment, it uses two files. One is called users properties and the other is called roles properties. And notice the location of these files. These two files together, the users properties is going to give me the ability to provide simple name value pairs that would be captured as the user ID and the password. User ID, password, simple user registry. The roles properties files allows me to define by user ID, name value pair in a property file, by user ID, the roles that they are a member of. Okay? So I've done this piece here, and notice this name here for application policy. And this is the exact same application policy other than the name change that's being used in the template right above here. They're using a different list of property files, but this one works just fine as well for a test environment. And if you open these property files, these two property files particularly, out of the box, they'll have kind of goofy user ID and password, like Kermit the Frog is the password in the JBoss test environment. I did a little modification for professionalism, but we'll see it in just a second. So login config is the JBoss configuration file to load various login modules from the JBoss security service. Another piece of configuration information to map those modules by name in my global namespace is the jboss-web.xml. I'm going to open that. We'll leave this open. And I added to this file something called a security domain. Security domain with the name that I added in login config. So this name must match what's going on in, or the name that I created for the application policy. Okay? Now let's take a look at, from login config, let's take a look at these two property files. From Eclipse, I can open these property files in the JBoss environment in the same folder as login config. Notice there's a props folder, okay? And let's look at, and go ahead and open up, use my shift key. I should be able to open both of them at once. Let's look at the roles and the users, okay? let's look at users first because it's more interesting. So here I can supply a user equals and a password. I can supply multiples. Let's test it with one right away. And notice in the roles field or in the roles file, I took the same user and I made sure they're a member of the admin group. The use of these two properties files using the basic login module in login config and binding the application policy from login config to the JBoss environment using JBoss Web XML should give us just the minimum amount of a user directory test environment necessary to test the security logic in our application. Let's try it. I'm going to first right-click on the JBoss server. It's stopped, and it says it needs to be republished, so I'm going to try publishing it. And make sure that I have my publish errors separate from my startup errors. And I do. Everything looks good so far. So let's try running now that our application is published successfully. Let's try a simple request to run a particular resource on our application. Okay. We've configured security in JBoss. We've applied security and constrained all resources within our application. So what would be expected to happen is that based on the Web XML, it says we now have form-based authentication. It should prompt us to type in a user ID and password. So what we want to try is running it, making sure that we can log in with our known user, which right now is only one, with our known password, knowing that that user is a member of that role. Then we'll try logging in with an unknown user, make sure that that works, and then we'll try a couple other things. Let's see how this goes. So we're going to run a servlet, which is a requestable URI addressable resource. Right-click, run as, run on server. So I'm watching JBoss start up, but I shouldn't watch. There's no need for JBoss to republish because I did that separately. JBoss is starting with its security configuration as I modified those files. And I get my login page. So what was our user? Our user was Pamela. And her password was password. Now, this is nice on testing, but obviously we want to mask this HTML field. But when I'm testing, I always try to make sure I can see the password at first because I make typos. And so if I click login, what I expect is that the server will look in those property files, discover that I'm a valid user, and it's not. Look at that. What's the password? Well, I can check in my users and see I typed in the wrong password. See? Wrong password. So the error works. Let's try the correct password. So my password is the password. Okay? And I log in and I see the execution of the requested resource. Right? That's what I expect. And we already demonstrated, because of my typo, we demonstrated that if you type in the wrong password, you will be prompted again. In other words, you get the login error JSP. You're typing in the wrong information, and it actually flips over to login error, but it has the same UI. Let's try it again with an unknown user just to prove that our application security is working as expected. So we'll try John, and the password is password. I can't remember John. It doesn't matter because it should fail. That's what we expect to happen, right? And it fails. Well, it fails by presenting us with the login error page, which is prompting us to log in again. let's add John to our very sophisticated user database, which is really a property file. And notice that JBoss has clearly documented a sample user properties file for use with the user's role, right? So this is no substitute for LDAP for sophisticated SSL configuration, but we want to avoid doing too much server configuration for our application test environment. So let's add John, and let's give him a password of password John. Now you guys remember that, and I'm going to go ahead and save it. We may be able to log in. JBoss may be unloading and reloading its own security mechanism, but let's try it again without restarting the server and see what we get. Right? This is a different error, right? So now it sees John, it recognizes John and his password, and I didn't have to restart the server because it takes so long. But now it's saying access to the requested resource has been denied. Why? We added him to our user list, but we didn't add him to the admin role. Okay? So we need to also, because we've constrained our resources with security constraints that are mapped to security roles, we need to make sure that John is a member of the same role, admin. Okay? So I'm going to modify the roles.properties and save it. And let's see if we can get John logged in this time. Okay, so now it's failing a security check. So before I check anything else, this is a different error, I'm going to assume that the server needs to be restarted. Why? Because the security module is loading and caching user information. So I could sit here and hit refresh, which is not very exciting, or I could make a full and complete restart. So everybody, please remember John's password and that he is now a member of the admin role. And the admin role is what's securing our application. So I'm going to go ahead and execute a restart on our server. Make sure all my browser windows are closed, which they are. Sometimes I get so many browser windows open that I'm looking at the response from the wrong one, so I make sure that browser windows are closed. So I'm restarting the server. The server is restarted. And it shouldn't be necessary, and it wasn't necessary for me to republish the application because the changes I was making in the properties file, in the login config file, those are actually in the server environment. They're not in my application environment. So if I execute my servlet again, run on server, and what was John's password? I believe it was password John. He should be a member of the admin role as configured on the server. And voila, John has appropriate access to our resource. If I try and execute this again, use the back page, let's close this browser, run it again. And I always want to do a sanity check, especially when I'm doing security. John and the wrong password, blah, blah, right? This is what I expect because he has the wrong password. Make sure that Pamela with her password still works because I added an entry there. So those kinds of checks are always good to do for sanity. Yes, security works. I'm getting what I expect. Make sure that your application can't be accessed by people who shouldn't have the right to access it, whatever your user configuration is. So that gives us an idea, looking at our primary focus here as JSP and servlet developers is what we need to do in WebXML to apply role-based security or Java EE security to resources that are provided within our application.